Introduction to Green Theorem and Stokes Theorem. Based on Khan Academy, both theorems are expansion of fundamental theorem of calculus that allow us to link integrals over two-dimensional arrays to single integral over their border. Green theorem is relating a double integral over a plane region to a line around its plane boundary curve. Its formula is double integral in the bracket dn over dx minus dm over dy. Integrate over dA. Green theorem has three types. First is a rectangular coordinate type 1. The second type is rectangular coordinate type 2. And the last type is the polar coordinate, where dA is equal to r dr d theta. Stokes theorem is relating a surface integral over a surface to a line integral around the boundary curve of S or space curve. Its formula is double integral in space curl f dot n ds, where f is the everywhere in the surface that bound in closed curve C, while n is a unit normal to a surface. There are two types of a Stokes theorem. First type is the positive direction. The person is said to be walking in the positive direction of closed curve relative to the orientation of epsilon if the surface is on the person left. Second type is a negative direction. The person is said to be walking in the negative direction of a closed curve related to the orientation epsilon if the surface is on the person right. Applicable condition for the both theorem. Based on the Khan Academy, Green theorem only applies to curves that are oriented counterclockwise and it have in the two dimension. Stokes theorem only work if you can express the original vector field as the curl of some other vector field. Not applicable condition for both theorem. Green theorem only apply at the vector fields in two dimension. So if we given the three-dimensional equation, that's not useful if you would like to apply the Green theorem. While Stokes theorem, vector fields that appears on the surface integral side must be able to represent as curl f, where vector field f must be obtained or supplied to us.
Now, I'm going to talk about the similarities and the relation between Green's theorem and Stokes' theorem. But wait, what is so similar about those theorems? Okay, surprisingly, both of those theorems have a closed curve, line integrals, surface integrals, and an orientation of a closed curve, whether it is a positive or negative orientation. So wait, how does both theorems relate to each other? Okay, note that there are three things to be reminded. There are curl F, Green's theorem, and Stokes' theorem. Let's talk about that. Imagine this, an xy plane in 3-dimension or space, where fxy equals to mxy I plus an xyj. Using the curl F before, we can conclude that ijk partial differential with respect to x, partial differential with respect to y, and partial differentiation with respect to z, and since there is no vector of k, therefore it's 0. After doing some calculation, it turns out that the answer will be partial derivative of n with respect to x minus partial derivative of m with respect to y times with k. Compare with the original Stokes theorem, we can conclude that it is actually a Green theorem where k equals to n equals to a unit vector. Therefore, Stokes theorem can be applied in Green's theorem.
Now we will talk about mathematicians that have contributed to the Green's theorem and Stokes theorem. The first contributor is Josh Green. He was baptized on 14 July 1793 and he passed away in 31 May 1841. The only education that he got is he went to Robert Goodacre School in 1801 for 1 year, and later after he published a few papers, he went to Caius College, Cambridge in 1837 and later graduated at 1839. After his graduation, he was offered a fellowship at the respective college. The contribution that he had made is he published an essay titled an essay on the application of mathematical analysis to the theories of electricity and magnetism. He published the essay in 1828, but at that time the essay was almost went unnoticed by many people. The second contributor is William Thomson. He was born on 26 June 1824 and passed away on 17 December 1907. He went to Glasgow University on 1834. Later, he went to Cambridge in 1841 and graduated in 1845 as a second wrangler. He was elected as professor at the Glasgow University in 1846. The contribution that he had done to the theorem is in 1845, William Thomson discovered about Josh Green's work, where he got a copy of it from William Hopkins. He later republished George Green's work, and together with George Gabriel Stokes, they made further advancement on the theorem and later published both of the theorem. The third contributor to the theorem will be George Gabriel Stokes. He was born on 13 August 1819 and passed away on 1st February 1903. He got early education from his father and a clerk who worked under his father at his father's church. He later spent 3 years in Rev. R.H. Wall Schools in Hume Street, Dublin, before entering Bristol College in 1835. Later, he went to Pembroke College, Cambridge in 1807 and graduated as senior wrangler in 1841. Stokes was encouraged by William Hopkins and the work of George Green to undertake research in hydrodynamics. The next contributor is Augustine Louis Cauchy. He was born on 21st August 1789 and passed away on 23 May 1857. He got an early education from his father and was also frequently visited by Laplace and Lagrange. Later, he was admitted to École Centrale du Panthéon in 1802, and in 1805, he took the entrance exam at École Polytechnique and successfully entered the university. Later, he graduated from the Polytechnique in 1807 and entered an engineering school, École des Ponts et Chaussées. For the contribution, Cauchy provided a written proof for Green's theorem when he was trying to prove Cauchy's integral theorem. And the last contributor would be Hermann Hankel. He was born on 14 February 1839 and passed away on 29 August 1873. He began his education in Halle, Germany, and later attended Nicolai Gymnasium in 1849. After that, he went to University of Leipzig in 1857 and continued his studies at Göttingen in 1860. In 1862, he obtained his PhD for a thesis, and after completing his degree in 1863, he began teaching at Leipzig University. He was appointed exceptional professor in 1867 there. For his contribution, he provided a proof for Stokes' theorem. So let's represent the history of Green's and Stokes theorem in a timeline. So starting from 1828, Josh Green published a paper titled An Essay on the Application of Mathematical Analysis on Theories of Electricity and Magnetism. The paper was not famous and almost went unnoticed until 1845, where William Thomson discovered the work of Josh Green and republished it for the public. He received the copy of Josh Green's work from William Hopkins, his coach at Cambridge. In 1846, William Thomson collaborated with George Gabriel Stokes, and because they share the same interest in Josh Green's work, they discovered Green's theorem and Stokes' theorem from the essay that Josh Green that have made. In the same year, Cauchy provide a written proof for Green's theorem while he was trying to prove Cauchy's integral theorem. Later in the timeline, in 1854, Josh Gabriel Stokes started putting up Stokes' theorem as a question in his students' exam for his student to prove. Because Josh Gabriel Stokes likes to put up the theorem as a question, the theorem was named after him, which is Stokes' theorem. And there is no evidence that his students have proved the theorem, except in 1861, Hermann Hankel provided a proof for Stokes' theorem.
Assalamualaikum warahmatullahi wabarakatuh. In this slide, I will talk about how Green's theorem and Stokes' theorems arise because of investigation of electricity and magnetism. In mathematics, electricity and magnetism are important elements that could form a basis technologies. The one that brought this important element to the world is an amateur mathematician, Josh Green. The first step that he took is he published an essay called Application of Mathematical Analysis to Magnetism Theory in March 1828. In his work, he introduced the concept of potential function and how to conduct the function. This essay includes the important formula known as Green's theorem. Sir William Thomson, as known as Sir Kelvin, helped Green's work and reprinted in the German Mathematical Journal in 1850. Sir Kelvin published a smooth function solution to Laplace equation. Hard work Sir Kelvin and Green allow us to determine the potential for the spatial domain. Josh Green also established Stokes' theorem. Sir Kelvin rediscovered Green's work and found it contains Stokes' theorem. In 1846, he is a professor at Cambridge and worked with George Gabriel Stokes. They sharing their ideas, including Green's work. Sir Kelvin then moved to physics and engineering and made great strides in the theory of heat, electricity, and magnetism. In 1854, Stokes wants to challenge his philosophy in one of his tests. As a result, one of his students, Hermann Hankel, has demonstrated his theorem in 1861. Hermann Hankel proved Stokes' theorem in the treatise on flood motion.